What is an exponent? First of all, what is an exponent? To start, look carefully at these two expressions. The first expression shows the factors 3 and 4. We multiply the two factors together to get a product of 12. The second expression is also a multiplication problem. It can be read as 3 to the power of 4 or 3 to the 4th power. The product of this expression is 81. So how does 81 come from 3 and 4? This expression can't be solved by multiplying the two numbers together. You see two numbers just like in the first expression, but these numbers have different roles. The expression 3 to the 4th power is called an exponential expression. In an exponential expression, there is a base and an exponent. The base of an exponential expression is the factor, and the exponent tells us how many times we're going to use the base as a factor. In other words, how many times the base factor is repeated. So for this expression, the base 3 is repeated 4 times. Here it is in expanded form. The problem reads 3 times 3 times 3 times 3. To solve this problem, just multiply the factors together like any other multiplication problem. Don't forget that you can use the multiplication properties as you work. The associative property would be great here. It allows you to group factors together in parentheses, which makes solving problems quicker and easier. If we multiply 3 times 3 in each parentheses, we end up with 9 times 9, which equals 81. So, 3 to the 4th power equals 81. An exponential expression is a fine example of what is called a mathematical notation. A notation is a shorthand way of writing something. While the expanded form of 3 to the 4th power, 3 times 3 times 3 times 3, isn't really that long. Imagine how long the expanded form of something like 7 to the 50th power would be. Being able to write an expression in a more concise notation can really be useful. Exponential expressions are read by identifying the base and saying it's raised to the power shown by the exponent. So this expression is read as 5 to the power of 6, or 5 to the 6th power. How do you think we would read this one? That's right, this is read as 10 to the power of 12, or 10 to the 12th power. There are two special words you need to know when the numbers 2 and 3 are used as exponents. Exponents of 2 are read as the base squared, while exponents of 3 are read as the base cubed. So here we have 5 squared, and this is 4 cubed. Exponents are also used to write powers of 10. You remember that we use powers of 10 in Lesson 2 to quickly and easily multiply decimal numbers. Well, powers of 10 are simply the factor 10 multiplied by itself a certain number of times. For example, 1000 is 10 times 10 times 10. Can a problem like that be written in exponential notation? Absolutely. We can write 1000 as 10 to the 3rd power, or 10 cubed. An easy trick to write powers of 10 in exponential notation is to count the number of zeros. That number is the exponent for the base of 10. Let's look at some more examples. The opposite is also true. You can easily expand a power of 10 shown in exponential notation by writing a 1 followed by the number of zeros shown by the exponent. So, 10 to the 8th power is written as this. So now you know that exponents are a way of showing repeated multiplication. Happy multiplying!